through some of the parts of the assignments I've received and comment on them, what's going on, what isn't going on. And we'll pick the one here that I just got done looking at. Okay, so let me run this. Okay, if we look at this, we get camera being, let's see, I'm looking at the old version. Let me look at the new version. If you were to focus on this, okay, which is wrong, but at least it's in the neighborhood, but take a look at that, okay? We are not 277 feet back from the target board, so there's something going on there. And I think what's going on there is this image. If you look at the world points, remembering that the checkers are supposed to be 3 inches apart, okay? It doesn't have any idea what the world points are. They don't make any sense whatsoever. And what's plaguing us here is if you have an obscured checkerboard, the detect camera points algorithm just goes to hell in a handbasket. Does not work, period. That doesn't mean you can't use the image. What it means is that you can't use the checkerboard points determined by the algorithm. All right. What you have to do is you have to do a few by hand. All right. How many do you need to do by hand to get any extrinsics? You need four pairs. All right. So you could do the 4 extreme corners. If you wanted to add a few more, you can do that as well. But with that box sitting in there, it has no way of determining a reasonable checkerboard.
I think I had another updated version of that.
Another update, even more recent than this update?
It was just my second update, so I don't know.
I think I got 2, because I got a V1 version and a V2 version. Let's look at, this is the V2 version. Let's go look at the V1 version. Here's the V1 version. here you had run on distort image, which I don't think helps. I haven't tested this, but basically, I think when you give it the camera params there, it might use the on distort image part of it. I don't really know one way or the other, all right? But I usually don't give it an on distorted image when I'm trying it. But it's still got the same problem. If we look at the world points here, well, the numbers are a little better as far as, I mean, they make at least, except it can't go to 30, can it? Because if it starts with 3, it can only go up to 21. I mean, it starts at 0, 3, 6, 9, but it can't, none of our images go bigger than 21. So there's still a problem here.
I think I was running it without with the image without the box on the checkerboard. And it was
Yeah, that's why we took a picture without the box.
Yeah, and I think I used that in the second version.
That's not the image that shows though when I ran it. Let's see if you have the image there. I've got, which image should we try?
I think it's image 2.
All right, let's do that. Whoops, let's go. Let's change it to image 2. These are better numbers, except I still don't like the camera height. So let's take away okay, so a little bit more believable.
I think I had an updated version of the camera frames too. It should be
Yeah,
the same.
yeah, because if you look at that 6 feet, this is the floor, right, the table. So we're asked to believe that the camera was 6 feet above it. And I can't even reach 6 feet above it. So don't think that's right. Okay. I don't know what's wrong here, though. Okay, because from the code that we changed, I don't see what we're doing wrong. The only thing I might suspect is maybe it's not finding the camera points correctly, the image points. Let's look at a different one. I see. Okay, so now we have 2 feet above the tabletop, right? Which is about here, more or less. You believe that? Yeah, yeah. I remember extending the tripod out so I could look down. So, and the camera's about here. So, 4 feet back from the top edge of the camera. Well, that's the issue. You got to know which corner of the checkerboard did it use as the origin, right? Before you can really judge that. So there's a little bit of extra code in here. I think it's this one. Okay, so that says that the origin of the checkerboard is pretty far away, right? It's the top right corner there. And the x-axis is the red axis, so it's coming this way. The y-axis is going that way. So we're asked to believe that it is 4 feet along the x-axis. Here's 2, here's 4, and then 2 feet along the y-axis, which puts it here, and then up looking down. So I believe these numbers, all right? I mean, at least they make sense to me. Don't know why your image looked very similar to this, I think. I can't figure out just by looking at the code what's going on.
I think there was something wrong with the calibration that was
Now
made.
that's the only thing that we haven't checked is I pulled one of my calibrations off. So the calibration can be an issue. Now, you were having problems too.
Yeah, I tried to calibrate all of the checkerboard without the product boxes.
Now, you got another problem.
Yeah, so I think I did.
No, I know what it is, all right? I was looking at the information about the camera, and you know how I have to set the zoom right?
Oh, yeah.
And it looks like it was set just a teensy bit wrong. It's supposed to come out a focal length of 8.8. And I think it came out 10
I got you.
or something.
So I should use an old.
No,
calibration?
you're just, you don't have a calibration
Right.
because unless you try scaling the focal lengths and
Okay.
using it, so.
Okay.
Which doesn't mean you can't go on to 2,
Right.
2 and
Yeah.
3.
Yeah.
It just means you can't use the information from 1 as a help.
Yeah.
But I think, and you mixed it in with old images, so you had some images with the 8.8 and the one image with the 10.
Right.
Okay, I can't remember who did it, but one of you. Basically, we're trying to render it and make it look like the image, okay? And there are some issues here. At least one of you stopped right here, okay? did not go on and set the camera right. Okay, and I'll show you what happens when you don't do that. Okay? And I have the same problem. There's OpenGL hardware, OpenGL software, and you were telling me that OpenGL hardware gave you a semi-transparent look. Right? Who was it telling? I think you were telling me. You had a note in the, or maybe that's my note, but whatever. I have trouble with OpenGL hardware, at least on my machine. All right, let's run this section. Oops. We are bombing. Why are we bombing? Right. Oh, there's target board. That can't be good.
You have to double click on the file, because you're not in that, that folder. If you go back to the other screen, the command window.
What are you saying?
Like if you scroll up in that window, you have to double click on the folder probably to product.
Oh. Oh, I'm in HTML? No.
You have to, yeah, there you go.
All right, let's try that. Okay, if you stop here, okay, a couple of things you can note. Where does the vanishing point look like it is? Where does the image look wider and where does it look narrower? Or does it? Okay, not quite right. This is not a perspective view. This is an orthographic view. To me, it has the illusion that it's getting narrower coming down that way. The other thing to remember or to note here is look at the x-axis and y-axis. Okay? What are the dimensions, first of all, of x and y? We are going, in effect, I know where this came from, for whatever reason, I decided that centimeters was a good unit. So this is dimensioned in centimeters. 60 centimeters is approximately 2 feet. Okay, so. Also, where is the camera looking? Camera's looking, hard to tell, but somewhere around in the middle. Okay. Where's the x-axis? It's in that direction. When we did the measuring, dimensions, the checkerboard, where was the x-axis? That way. Okay, so the x-axis was the negative of what the original y-axis was, or what this y-axis is. And the y-axis here is going that way, and the y-axis that was done when I found the checkerboard was down that way. So you got to watch out how that affects the location, because the z is fine, negative z, that's definitely the height here, But if you look at the X, you've got to, from the standpoint of this camera and this coordinate system, you got to make the X difference in the negative Y direction and the Y difference in the negative X direction. You've got to change those and change the sign. Also, where's the origin in our original image? It's the top of the image there, right? But here, we're looking more in the center of the image. So when we're looking at the location of the artificial camera, that's going to be relative to someplace in the center of the image here. So we have to subtract off a little bit less than a foot one way or the other when we're computing where the location is. Right? So we got a little bit of fudgy math to do in here and changing things around to get things to work right. There's a parameter called cam target. Cam target tells you what you're looking at. Okay, so here I set cam target to 0, 0, 0. That means it's looking right down to the center of the checkerboard. Okay. If I don't set cam target, just leave it out. But identify it anyhow. So I'm going to print out the camera target. Does the image look any different? Not really, but it's a tiny bit different because the default cam target is 0, 0, and up a little bit. Okay. And how far is it up? Well, it's up this high. So the cam center, or target, is approximately right here, rather than being approximately right there, which it doesn't really make the image look any different, okay? Or at least not enough to have any big artifacts. Okay, how about the camera view angle? Because remember, this is perspective, so we need to, this image is orthographic, so we need to do a perspective, which means we need a view angle. What are we going to use for that? Answer is, I'm not positive because it depends. The angle is determined something related to that distance. Okay, you take